as well. So we have a lot of definitions today. I apologize for that. But I think on your handout I have like all these different sampling methods. So the first one, that first picture is what we discussed yesterday, the simple random sample. So maybe we need to go ahead and throw a definition in there just in case. So in a simple random sample. Hello. No problem. Yes. She was in my room. No, because I don't think I knew that's where she was supposed to be. So I will talk with her. Okay. Thanks. Bye. Alright. So a simple random sample just means everything is equally likely to occur. So everybody has the same probability of being selected. All right. Then the next option on here, the stratified sample, is basically when we take a population and divide them into groups and get a simple random sample from each. Okay, and those groups have something in common. I don't just randomly assign groups. So, for example, in our high school, we could easily do stratified sampling if we break them into groups: freshmen, sophomores, juniors, seniors. Does every student in the high school fit into one of those groups? Yes. Does anybody fit into more than one? No. So they're completely separate groups. And then I could get 10 people randomly from each group. So I have everybody represented in my final sample. The different groups that we divide them into, those are what are called the strata. So just another name for the groups. Can you guys think of another example of stratified sampling we could do? Age. Does everybody fit somewhere? Yes. Could you fit in more than one group? No. So you have non-overlapping groups, and you could take so many people of each age in your sample. All right. The next option is a systematic. So that one is obtained by selecting every kth individual from the population. I'll let you guys write for a second before I talk. I know it's hard to listen. If I had every kth person, it might mean I stand at the front door of school and I say, okay, I'm going to ask every 5th person that comes in. So you have a K value, that's how frequently you pull one to go through. Or like we had that Coke example in homework. Was it last night or the night before? Maybe you stand and you take every 30th bottle of Coke that comes off the assembly line and they do whatever with those. So you have a certain value and you take one every so often. A cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Cluster sampling is easier, but it usually doesn't give a very good sample. So a cluster sample might be, okay, I want to know who the new Stuco representatives are going to be, so instead of asking everybody to vote, I'm just going to walk into this classroom and ask each of you guys to vote. You're a cluster. You're in a group. Every one of you gave me an answer. But would your answer reflect the entire high school? No, probably not. So it's easy and you get a lot of data fast, but it's not usually a very good sample to work with. The pictures, just trying to help you distinguish between the different options. So simple random is like when we number everybody off and we randomly pick a few numbers. Stratified, we break them into groups and then take the same number from each group, randomly select them from groups. So that's usually a pretty good one in terms of making sure everybody's represented. You know, if I were going to only pick a few people to vote, I'd probably want to make sure I had freshmen and sophomores and juniors and seniors represented. So that would be better than only asking you guys your opinions. Systematic, like we said, is when you number everybody and you take every so often. So this one, it started with the second person, but then we went every third person after that. So we just picked one to start with, and then every so often we take another. And then in cluster sampling, you just take groups, and then you randomly take everyone in the whole group. So our clusters could be each of the classrooms, and I randomly take a couple entire classrooms to represent. Do you guys kind of understand the difference in each of those? All right. So let's look at a few examples. Take a little break from writing definitions. In 2008, the United States Senate had 47 Republicans, 51 Democrats, and 2 independents. The president wants to have lunch with 4 Republicans, 4 Democrats, and 1 other. Obtain a stratified sample in order to select members who would attend the luncheon. So if I said stratified, what does that mean I have to do? Break them into groups. And what would the obvious groups be here?
Democrats, independents.
So we break them into groups. Okay, and then what happens? How do I get what I want? Take a random sample. So let's remember. Let's try our calculators. Do you guys remember how I could randomly get 4? So let's say I put them in alphabetical order. I've got all my Republicans in alphabetical order, my Democrats, so forth. So to select my Democrat people, you need to store something as a seed just to give it a starting point. So I'm just going to do 4. Then you hit store, go math, probability, and number 1, rand. And we won't have to redo that again. We've started the process now. Okay, so then if I go into math, probability, number 5, the random integer. I'm going to go from 1 to what for my Democrats? 51. Go ahead and put another comma. How many of them do I want? 4. 4 Democrats. So 1, 51, 4, and hit enter. And it gave me 51, 22, 46, and 45. So I would take the people in those positions on my list. Now, if you had a different seed, you got different numbers than I did.
Why do we get the same numbers?
Because we did the same seed. So the calculator is not truly random. It has a process of finding the random number. So if we start with the same seed, we get the same ones. All right, so now let's do our Republicans. So if we go math, random, or probability, number 5, random integer, we need to go 1, comma, how many Republicans? 47 total, and we're picking 4. So 1, comma, 47, comma, 4. And I got 36, 16, 16, and 23.
So if we get the same number twice, just put it on there.
Right. So can we have the same person twice?
Okay.
So what could I do?
Do it again.
Yeah, if you just hit second enter, it brings it back up. Let's just take off that comma 4 at the end. Let's just get one new number. And mine gave me 24. So you would have to remove anyone that's repeated and get one more random number. Alright, my other, so I need a random integer from 1 to 2. And I got number 1. So I have all of my people selected. A quality control engineer wants to obtain a systematic, what does systematic mean? Every case value of 25 bottles coming off a filling machine to verify the machine is working properly. Design a sampling technique that can be used to obtain a sample of 25 bottles. So how could we do it? We have to select every case bottle, right? Okay, so an example, we could survey every, and then you just pick something. Fifth bottle, starting with, okay, we could start with bottle 5, but couldn't I just have to start somewhere. So which bottle?
23.
Starting with bottle 23?
Yes.
Okay.
Or 6.
Or 6. Until we get 25 total. So you basically just have to find a place to start and then take every so many. There is a good way. We want to make sure that we would have enough to get 25 bottles. So what if I only make 100 bottles a day? Would I be able to get 25 bottles by taking every 5th one? No, especially if we didn't start until we got to bottle number 23, right? So we have to make sure we'll be able to get enough for our sample. So if you know your total population, if we know this machine is going to run all day and I'm going to make 5,000 bottles, would it really be good just to take every 5th one until I get my first 25? No, because then all my bottles are going to be collected by the morning, but what if as the machine gets hotter, it's less accurate? Wouldn't I want to pick all throughout the day to make sure I don't have any issues? So if you know the whole population, you can find your K value just by taking the population divided by the sample needed. So for instance, if it produced 2,000 bottles a day and I needed 25 in my sample, then what would we get? 80. So I would take every 80th bottle. If it doesn't work out evenly, round down. So if you got 80.3, you would still take every 80th bottle. Okay. All right. Let's do an example with a cluster sample then. So we've talked about the simple random, talked about a stratified and a systematic method. So if I said we have a school administrator wants to obtain a sample of students in order to conduct a survey. Give me an example using a cluster sample. Now I kind of already used one in the school setting. Can you think of another? Grades. So maybe if we want to do a cluster sample, we look at all the grades in the school and we say, you know what, I'm going to ask everybody that has a 4.0. Okay, would they really be reflective of the entire school? No, but I got a whole group, and in a cluster sample, you take everybody in that group. So that would be a good example. Let's think of some more examples of each of these. So let's think cafeteria. If I wanted a stratified sample in the cafeteria, what could I do? Okay, split the tables in half, or even take each table itself, could be a strata. And then what would I do? Simple random numbers for each table. So I would have to make sure every table was represented. So I had my non-overlapping strata, nobody's sitting at two different tables, and you take a few from each. So how would I do a cluster sample in the cafeteria? Take one table. I walk in and say, I'm going to ask everybody at this table, every single person in that group gets selected. How would I do simple random in the cafeteria? Random numbers. Maybe I have all the chairs numbered, and I go in with my list of random numbers, and it tells me which chairs to talk to. How would I do a systematic in the cafeteria? Yep. Just go down the row and talk to every 5th or 10th or whatever person. All right, makes sense? Okay. So, a couple other options for sampling. A convenience sample is one where the individuals are easily obtained. Kind of like a cluster sample, the benefit is it's easy to get the data. This is the one that when people do their final, they usually get docked on when they go to pick their sample because they do convenience. They ask all the people in the class, and then they might go next door and ask all of Mrs. Dyer's class, and then they've got enough people so they quit. Was that a good sample to start with? No. They were only selected because it was easy to get those people. Convenience sample, I walk in the cafeteria and I get the first 10 people that walk out to go to the restroom. Okay? Were they selected for any reason other than the fact that they were the first ones that walked up to me? No. So it's not really a good sample, but you can get it fast. So definitely not a good, not random at all. A lot of times it would be very biased. You know, if you only ask people in here in Mrs. Dyer's room, then you're only asking people in a math class. Maybe somebody in another class has a different opinion. Finally, if you're looking at true large-scale surveys, these are usually done using multi-stage. So really all you need to write down is it's using a combination of techniques. They don't just do one particular thing. They break groups into strata. Then they might break them into subgroups from there and then randomly select. So when you combine techniques, that's your multi-stage. An example, Nielsen Media Research randomly selects households and monitors television programs they're watching. They use a people meter that's placed on each TV in the household. It measures what's being watched and who's watching it. And then they select the households using a two-stage process. So this particular process, group one, or stage one, they take census data, they break the country into geographic regions, and then from those randomly take about 6,000 of those regions. So they broke the country up into groups, they took 6,000 of those groups, then they go and they break it down even further. So within each of those 6,000, they randomly select so many households within. Okay, so they broke them into groups, randomly selected groups, then within those groups, randomly selected people. So it was multi-stage. You guys see that? All right. Then the second thing we want to talk about today. So we talked about all the sampling. Second thing we want to talk about is bias. So, bias is when the results of the sample do not represent the whole population. So I got a sample, I did whatever survey, but in the end, my data is really not good. It does not reflect the true population. There's three main reasons this could happen. There's sampling bias, non-response, and response. So we're going to talk about those three things next. You can probably guess kind of what those things are. Sampling bias, the problem is with the sample. Non-response bias, what do you think that is? Someone that doesn't respond. And response bias, they respond, but it wasn't accurately. Okay? So sampling bias is basically the problem is with our sample. Different ways that might happen. We might have just picked like a convenience sample. We might have undercoverage where I don't really get the entire population. I left out one group. Or, maybe I took a sample of students in the high school and my sample was 80% male. Are 80% of the students in the high school male? No, so there was undercoverage with the females in our high school because my sample was drastically different than the population as a whole. So if the problem is in the group you chose, that's sampling. Non-response. Okay, I've already said non-response is when people don't respond. Why might that happen? Yeah, they don't want to answer. I think about every time I take my kids to the doctor, I get a call that night asking me to do a survey on my provider. And every time I just hang up. That's non-response. They're calling, they're trying to get my opinion, and I just don't do it. Okay, all those radio surveys, they're like, call in and tell us what you think. Does everybody that have an opinion call? No. So there's non-response. They don't take the time. And so those people that don't respond might have very different opinions. When would I be likely to respond when they call and ask me my opinion on my doctor? Probably if I'm not happy with the doctor. So they may get a lot of negative feedback. Does that mean there's something wrong with that doctor? No. It means the method they're collecting that is giving people the option to not respond, and if they're happy, they don't take the time. All those Google forms that get sent out to you guys asking you to vote for homecoming royalty and all of those different things. Does everybody vote? No. Is it possible that the people that didn't vote would have a different opinion than those that do? Absolutely. So that's non-response. Wasn't because we picked a bad sample, it's just because people didn't answer us. I know it's a lot of writing, guys, but I promise tomorrow is our last day in chapter 1, and in chapter 2, there's not a ton of definitions. Okay, so it gets better. All right. So response. people do respond, but they don't tell you what they really think. Why would they take the time to respond but then not tell you what they think? Pressure. If my doctor hands me the paper before I walk out of the office and asks me to fill it out and give it back to her, am I going to write something bad when I'm handing it right back to the person? Probably not. Not unless you're really gutsy. Most of us would feel a little guilty doing that. Or maybe they ask the question in a really confusing way. You know, have you ever taken a survey where it's asking like, I do believe this, I do not believe this, I have not, I would not. When they start throwing a lot of those things in there, does it sometimes get confusing? Yes, sometimes things are worded weird. Sometimes it's the way a question is asked that makes people feel like they can't give their real opinion. So I might say, okay, Carson, don't you think I'm doing a great job teaching this class? Like, is Carson going to want to argue with me right now? Probably not. So the way I asked it was kind of leading him. Like, what is he going to say? Yes, because I kind of led him to say yes. The order of questions. You know, sometimes, have you ever taken a survey and it's like 75 questions long and you start out like really agree, disagree, okay, wow, I've been doing this for a long time, agree, because I'm sick of this. Yeah, so if something's really long, we might just pick an answer to be done. So there's a lot of things that people respond, but it's not really going to give us their true opinions. Does that make sense, everybody? I want to do one final slide. Last one. With bias, error and bias kind of go right hand in hand. They're both problems with what we have with our data. So non-sampling errors results from obtaining and recording the information. So maybe I had everybody fill something out. I have a survey, and I have it pulled up on my computer, and my kids come in after school and start typing and overwrite some of the answers. Okay, I had a good sample, I got the real data from you, but something happened to that data, so it had an error in it, so that's non-sampling. The sampling error is just like sampling bias. It's when the problem is due to the sample being different from the population itself. Once you get those written down, I am done for the day, and there is a handout on